This is British Columbia. The air is crisp. The summer colors have begun to transform into fall's many hues. On the river, the water's flow increases as nature prepares for the return of the salmon. This is the conclusion of a long, arduous journey in which sockeye salmon travel thousands of miles before returning to spawn in the exact spot where their lives began. Their journey over, they die. Their bodies enrich and revitalize the stream and provide nourishment for other wildlife. While sockeye salmon spawn in the fall, other members of the family of fishes known as salmonids, which include other species of salmon, trout, char, whitefish, and Arctic grayling, spawn at different times throughout the year. Each in turn requires a particular type of habitat at specific cycles in their lives. Their requirements for food, water flow, water temperature, water quality, passage, and the presence of cover and shade varies and are different for each stage of their development. There is not one simple answer to the question, what constitutes an ideal habitat? Because when you talk about habitat for salmonids, you need to qualify the fish species and the development stage. Adding to this complexity are the geographic differences between coastal and interior watersheds, as well as the climatic changes brought about by the changing seasons. These are all factors that directly affect the survival of salmonids. All salmonids begin their life in fresh water. Some species of salmonids complete their entire life cycle in fresh water. Others migrate to the sea, only to return to their natal stream to spawn. These migratory species are known as anadromous, and depending on the specific species, spend a few months to several years in the open ocean. For all species, the process of creating new life begins with spawning. Mature females use their powerful tails to carve out bowl-shaped recesses in the gravel known as redds. It is here that they lay their eggs. The males then release sperm to fertilize them. The fertilized eggs are then covered and protected by the gravel. When these eggs first hatch, they are known as alevins. At this stage in the life cycle, they have yolk sacs attached to their bodies which provide a temporary food supply. They move through the gravel, surviving on the nutrients of the yolk sac. This protects them from most predators until they are mobile enough to emerge and begin feeding on aquatic insects. Once they've absorbed the yolk sac, they emerge from the gravel and make their way to the surface as fry. At this early stage, fry tend to remain in shallow water and close to cover. However, some species move up or downstream to a mainstream river, a lake, or directly into salt water. Salmonids feed during the day and actively at dusk or dawn. They eat insects that fall on the water surface, such as mayfly, blackfly, and caddisfly adults. They also eat the larval stages of these and other drift insects, as well as crustaceans, leeches, and the eggs and fry of other fishes. As the fry grow, they are referred to as juveniles, or parr. This is the stage where many species develop distinctive barred camouflage patterns on their sides that allow them to blend in with their surroundings. Those that move to more open waters will lose their parr marks, instead developing counter-shaded patterns. Their backs darken, and their bellies and sides become silvery. The spring marks the beginning of the stage when the anadromous species migrate to sea. During this stage, they are known as smolts. All salmonids, whether freshwater or anadromous, complete their life cycle by returning to spawn in the gravel from which they emerged. Members of the salmon species die shortly after spawning. Others, like trout and char, may live on and spawn again. As their bodies decay, nutrients are released into the stream, enhancing algal production. When the new generation of fry emerge in the spring, they feed on insects which thrive on this rich food supply generated through the decomposition process. It is spring. Air and water temperatures are rising, and life is renewed on the water for another year.
Here on the Keogh River, northern Vancouver Island near Port Hardy. It's a river about 34 kilometers long that flows into Queen Charlotte Strait. This is the maximum activity in terms of the fish moving, fish emerging from the stream. Now, if you look over here, you can really see the type of activity we just had here. Look right here, there's a major steelhead spawning area called a red. It's about 1.5 meters by 1.5 meters in size. You can see all the rocks have been disturbed, and that is the area where they choose to spawn at the tail out of a kind of a shallow pool just at the head of a riffle. That's where they'll get their maximum survival rate because of the amount of oxygen and flow that's going to percolate through the area at the top of a riffle. Now, after the eggs incubate for several weeks in here and finally emerge, then those fry have to move and get out of the faster water, get to shore and rear in that very slow water that's on the sides. And it's loaded with insects that time of year because you have your maximum amount of insects in the spring. They have to go in there and start feeding heavily on them to grow and rear for the whole summer. They gradually, again, start to move back out from the edge of the water as they grow bigger and bigger. And they come further and further out in towards the middle of the stream as they get to be large fish or par.
Salmonids, which spend time rearing in streams, are territorial. The size of the territories they defend are related to the size of the individual fish, as well as the availability of insects in the stream.
This area is about as best as you can get in terms of all the habitat features for the spring period. You've got everything here in terms of lots of complexity, diversity. You've got all the nice leaf litter and the nitrogen fixing alder. And then you got all the nice logs and with their masses and complexities and nooks and crannies that maximize survival rates of all the species at this time of the year.
From the early spring into June, the par are growing at their highest rate. The smolt migration will occur in May, after the fish have taken advantage of the abundance of food that's available during the spring. The summer months bring higher temperatures and lower water levels to the river. This is a time when cover and shade are crucial to the survival of the salmonid. Habitat requirements can differ dramatically between coastal and interior watersheds. The lusher coastal systems often have slightly cooler waters, more cover and shade than their interior counterparts.
This is the Keogh River in summer, and we are just south of Port Hardy. Right now we just finished the smolt migration out, so there's no adults in the river in the summer. Pinks will probably be starting to be in this area of the river in late August, early September.
In the summer, steelhead fry prefer the fast water of riffles, while coho fry prefer slower, deeper habitats, either in the main stem or off-channel. Steelhead par prefer deep, fast habitat near boulders and woody debris.
This river definitely has some good coho habitat in it, a lot of good swampy off-channel habitat in the lower end where coho are rearing. As well, it has a lot of large woody debris and cool riffle sequences with lots of refuge and some good back channel and side channel habitat. The complexity of having old growth right to the bank where it creates undercut banks and lots of cover along the edge habitat for refuge for fish. As well, you can see here we have riffle section, that's where the fry would be. And then as they get bigger, as coho par or steelhead par, they also have pools to move into for feeding. All the habitats here are covered for all the different life stages of the fish. Sometimes in September here, we'll have long periods where there's no rain. Temperatures could get to be lethal, above 20 degrees Celsius. And in those instances, that's where pool habitat, deep water habitat is really important, because if they can go down deep, the water temperatures are usually cooler for them.
We're here on the Nicola River, about halfway between Merritt and Spencer's Bridge. Right now in the pool beside us, we've got Chinook salmon, adult Chinook salmon, holding prior to spawning, and spawning will commence in about 3 weeks' time. We also have some juvenile fish around the edges, and downstream in the cobble area and the big boulder chutes down there, we probably have steelhead par. A healthy habitat for juveniles and mature fish in these systems, I think, is driven by cool, clean water with a reasonable supply of cover and relatively stable banks. Good habitat depends on what fish species and what life stage you're talking about. If we're going to think about our adult Chinook moving up the river right now, what constitutes good habitat for them prior to spawning is deep pools that they can move through and hold in. It provides surface cover, they can't be seen from above, so they're relatively immune from predation. Ideally, it's got a nice even flow to it and some influent groundwater to keep the temperature cool. There's also a number of springs and side channels coming into the Nicola that again are fed with this cool groundwater. So in those springs and in the places where the groundwater wells up in the system is where you tend to find, or may tend to find, the concentrations of juvenile and adult salmonids during these periods of extremely hot weather and warm stream temperatures. First thing in the morning, we observe Chinook fry feeding along the margins of these pools. They're typically feeding on mayfly spinners. As the water warms, the amount of dissolved oxygen that's available for the fish decreases. They have to change their behavior to go to somewhere where there's a tolerable dissolved oxygen level, tolerable temperature levels. During the night, the air temperature in this interior zone cools down substantially to 15 or 16 Celsius. The adult fish, like I say, they'll migrate through here at night, and if the temperatures stay cool enough, they'll continue to move all day. In the next few weeks, the adult Chinook are going to be moving through the system into the deepest pools closest to the areas where they are going to spawn. The females will spread out onto the spawning grounds, long, shallow sort of glides, tailouts of pools, nice cobble, and these fish will then start to dig redds, and the more digging that goes on, they start to create dunes on the river. In certain places it gets wider and wider and wider, or sort of more spread out, and sometimes you get dunes that'll be the entire width of the river, 5 to 6 feet or 2 meters even, from the bottom of the dune to the very surface of the dune up here, and the water kind of flowing in a large roll over the dune, and you'll see spawning pairs all over this dune, sometimes 50, 60 fish wide across the river, all spawning and doing their thing up on these dunes, and it can get to be pretty spectacular. We've had areas on the Nicola of possibly 100 meters plus of the river where it's just one dune after another and spawning pairs up on top of it.
The fall months bring cooler temperatures and increased water flow. It is a time when there will be a number of species on the river system. Each species has different habitat requirements, using different portions of the river system to spawn. On the Chilliwack River, pink salmon are the first to spawn. Later in November, chum move in. During the cooler months of December and January, coho salmon choose red sites where there is an active upwelling of warmer groundwater that stabilizes the water temperature.
We're in the downstream section of the Chilliwack Better River. It's a medium-sized stream, pretty typical for the lower Fraser Valley. It's high mountainous drainage, and then it breaks out into the Fraser floodplain, so it widens out and you get these wide gravel bars and multiple channels. And that usually indicates that we're getting a lot of gravel moving down through the narrow parts of the river, narrow steep, and then when they break onto the floodplain, things slow down, and basically we get these sort of delta deposits. Chinook salmon are very large fish, generally the biggest salmon we have on the coast. And what they can do is they can pick areas in higher velocities, higher energy, and much larger gravel. What that means, the larger gravel has a higher chance of staying in place in a flood. So what they do is you'll see them out in heavier water, faster water, digging reds and big gravel. That's their strategy. Pink salmon are, in contrast, are pretty well the smallest of our salmon. What they tend to do is they tend to spawn out in the main stem in smaller gravel, but a lot of times in these wide shallow flats where the river in a flood can spread out so the velocities don't get as high. Now chum salmon have another strategy. They overlap with pinks where they spawn, but they also use groundwater, so they go on the inside of corners of the river, the quiet water on the inside curve, and they're using groundwater along the bank. And behind us along the bank you'll see the fish are actually digging in the side of the river bars, and those are chum salmon. You have to visualize that in a flood, everything's moving along, the gravel's actually moving along the bottom. If you use gravel for cover, you're in trouble because it's mobile. What fish tend to do is they go to the biggest structure they can. It might be rock, boulder accumulation, but in the lower Vedder River, Chilliwack-Vedder River, it oftentimes is log jams or piles of logs that are reasonably stable. Looking behind us out in the floodplain, there isn't real big pieces of stable wood here, but there are some accumulations. There's one back there that's reasonably stable and there's enough mass. So when they talk about large woody debris, what they're trying to indicate is something that's big enough to be stable in most flood events, and that's where you'll find your fish.
While adults are spawning in the main channel, juveniles in the system seek slower moving water and the protection of undercut banks. Water temperature has a direct effect on the incubation of the eggs and the development of alevins.
And those eggs will go down, and it'll take about 300, it's called accumulated thermal units, or ATUs, till they become eyed. That's the eyes are visible in the eggs. And it's simply a calculation where it's the number of days times the average temperature in Celsius. So if it's 10 degrees Celsius today, it'll take 30 days to get to eyed. They will hatch in 50 days at 10 degrees, so at 500 ATUs they hatch, and they're not ready to emerge yet. They have big yolk sacs, and then they stay in the gravel to about 1,000 ATUs, so that's 100 days at 10 degrees.
The approaching winter months bring new survival challenges for stream-dwelling salmonids. This is the season of high mortality for juveniles, especially when winter storms bring flash floods and refuges are in short supply.
What we're looking at right now is Silver Hope Creek, which is just outside of Hope, and we're seeing some pretty high flows, which are typical in winter conditions after 3 or 4 days of precipitation. The habitat is limited at a time like this for fish because of the high velocities and lack of hiding areas for them, lack of areas of refuge to get out of the velocity.
Coastal streams, of course, tend to be a little warmer, so a lot of the precipitation in the winter falls as rain. So stream flows, even in the dead of winter, can increase very high during the winter time in coastal streams. In interior streams, precipitation will be more snowfall, so the water will get stored on the stream banks. And that means the regular stream flow within the stream proper tends to be much lower. This is an off-channel habitat area. It's separated from the main stem. It's maintained by a little bit of groundwater flow that keeps water temperature a little higher than you'd normally find in the main stem stream. It's also got lots of large woody debris available for the fish to seek velocity refugia from. It's also got lots of brush that act as complexity that allow the fish to minimize the risk of predation, those sorts of things. There seems to be some indication that some species like coho salmon will tend to prefer deeper pool-like off-channel habitats or off-channel ponds where they can hide amongst brush piles, woody debris, where there's virtually no current, then there might be some groundwater discharge. Other species, such as juvenile steelhead trout, or maybe even rainbow trout, you might find them still in the main stem channel, and they'll move in between the interstitial spaces of the stream substrate and can move quite far down. Extremely low water temperatures, of course, can, even though the water is flowing, can cause ice to build. Anchor ice can develop on top of the substrate, say in riffle habitats. That can lock fish below the surface of the substrate within the stream bottom. Then frazzle ice can also build up. When water enters into a pool or a riffle or something like that, it creates crystal particles, which eventually tend to form almost like a slushy material, and that can fill a whole volume of a pool. And of course, fish can't exist within that type of habitat, within a pool that's filled with this frazzle ice. So eventually that habitat shrinks right down. If the whole pool is filled and the fish have nowhere else to go, then that will kill them. Fish, of course, are going to have to swim against the current. When they swim, they contract their muscles, which burns energy. Because their metabolism is so slow, even if they can feed on, say, insects that are available to them in the stream, it takes them so long to metabolize that food that they basically can starve to death by the time they metabolize any sort of energy from their food. So fish have to have suitable habitat in which to minimize energy expenditure. If they don't, then it's likely that they will die because of starvation. It's important to have suitable habitat at all phases of the animal's life cycle, because if one becomes limiting, then it doesn't matter if you have excellent summer rearing habitat. If winter habitat, for instance, becomes limiting, then that becomes a bottleneck for the population, and the maximum size of the population is simply what can be produced by the winter habitat.
There is no such thing as a perfect habitat, because so many species depend on different areas of the watershed for different reasons. However, the basic requirements are simple: cold, clear water, plentiful food, cover, and accessible streams. Ultimately, if we wish to maintain healthy salmonid populations, we must understand the needs and requirements of these magnificent fish. By protecting watersheds, we will be able to ensure that species that have survived for millions of years will be part of our ecosystem for generations to come.